Welcome once again to another exploratory data analysis tutorial on our channel. Here we are performing exploratory data analysis on USA Census Income dataset and trying to visualize effect of different variables on the income. We will perform the analysis using Python Pandas. You will see and learn steps to create these type of charts. And just for representation, I have put all those charts in Power BI so that we can see all of them together. So we will learn all of this in this chapter. So let's get started. Hello everyone. Welcome once again to another Python exploratory data analysis tutorial. On request of one of the students, we are doing census income dataset analysis. To perform exploratory analysis on census income dataset, the dataset that we are using here is this census income dataset called adult here. And here in the dataset we have variables like age, work class, education number, marital status, occupation, relationship, race, gender, etc. So what we are going to do, we are going to simply use this particular dataset here. And in order to install or import this dataset or use this dataset for exploratory analysis, we are using Google Colab here. We have connected Google Colab to the Python 3 Google Compute Engine. So you can simply connect and then you can type this particular code here. So to import the dataset, we'll use import pandas SPD because we want to import it in pandas data frame. We will write the name of columns here in a list because these are the names given here. And then we are using the URL load the dataset from the UCI repository, which is this particular URL. And here we are using pd.read csv and header none names is equal to columns and na values we will use with question mark and skip initial space is equal to true so that we get the clean data. And we will also, so in the data set we have test and training data. So we will not print the test data right now. When we will apply some machine learning algorithm here or we'll create some machine learning model here, then we will use this for evaluating our model. So for exploratory analysis, we will simply write data dot head here and this, let's display the data set. And now you can see, so in the data set we have age, work class, final weight or final WGT. Let's see what this is. So this is final weight in the UCI adult census income dataset. Represents the number of people in the US population that the current record is estimated to represent. It is weighing factor calculated by Census Bureau. In simple terms, a higher value means that the record represents a larger group of people in the population. It is used to adjust for oversampling or undersampling in certain groups to ensure the dataset reflects the population accurately. Typically, final weight is not used directly in machine learning models unless weighing it explicitly is required. So just keep a note of that. For exploratory analysis and graph visualization, we will import cbon as SNS and import matplotlib.pyplot as PLT, which will be used for plotting different type of graphs in the with this data set. The column income is given as greater than equal to 50k, less, something like that, less than equal to 50k, less than equal to 50k, and so on. So if you just want to see the distribution, we can write something like data.income dot value underscore counts. This value underscore count method, when you select a categorical value variable and use value underscore counts, so it will show you number of samples of each value there. So here you can see less than equal to 50k or greater than equal to 50k. So we have 24,720 records of less than equal to 50k. So we can also convert this into a binary. So we will simply convert this into a binary variable. For this we will use a code and say convert income to binary for better visualization. So data income will be data income dot apply. So when you use lambda function like this, here we are using lambda x. That means if the value is above 50k, if it is written as greater than 50k in x, else below 50k. So here we are using the simple switch case kind of thing. And now when we will write data.income.value underscore counts, so we will see below 50k, above 50k. We will be simply using it like that. Okay. So instead of those particular symbols that we used here, we will simply use these wordings. Next, in the data set, we have a numerical value called age. So age of every person here is given. So we will see how the age is distributed. To see that distribution, we will use SNS style wide grid. This will create a white background for our charts. We'll use plt.figure. So that's why we have used matplotlib.pyplot, because with plt.figure we will create a fixed size of 8,5. sns.histplot. Whenever you have to see distribution of a numerical variable like age, you can use the hist plot or histogram plot. In hist plot, the arguments that you have to provide are data. You have to provide x, that is what variable are you selecting from the data. How many bins do you want? That means number of groups do you want, because age will be from minimum, age can be from minimum 16 to 100, right? So as per the description, so we are just creating 30 bins of age, 30 groups of age. You can also reduce this number to 20, and we are using the color blue. plt.title, chart title will be age distribution, x label age, y label frequency, and plt.show will show us the data. So now you can see from minimum to maximum value of 90 here as per in the data set. You can see most of the values are between 20 to 50 range. Here kernel density estimation, this curve that you are seeing here is because KDE is equal to true. If you will use KDE is equal to false, you will not see this. So KDE or kernel density estimation is a way to estimate the probability density function of continuous variable age here. It smooths the data using a kernel using a Gaussian to show the underlying distribution as a continuous curve, making it easier to identify trends or patterns. When KDE is equal to true in Seaborn's hist plot, a smoothed curve is overlaid on the histogram representing the data's estimated density. So this is just the smoothed version or smooth version of these rugs or these bars that we are seeing as per the hist plot. Now what observation do we have from the age distribution? Shape. The distribution is positively skewed, with most individuals clustered around the middle age range 25 to 50 years. Okay. Fewer people are present at the extreme ends, young and old ages. In young, there are some people like around 1500 you can say, but in old ages there are fewer people. The working age population dominates the dataset, which aligns the dataset focus on income and work related attributes. A KD curve helps highlight the smooth age density, showing peaks where the most frequent age groups lie. Basically on x-axis we have the age range. These are our 30 bins, and in our 30 bins, for every bin, what is its size, representing how many people are there in that bin. So for example, if we have a bin, let's assume if we have a bin size of around 5. So how many people are in the range 60, 16 to 21, then 21 to 25 or 26, and so on. So this is what this distribution plot will let us know. Next, what we can do, we can use income distribution by gender. So for doing that, we are going to use count plot. Count plot basically is used to, we can use two variables, and it shows the count of observations in each categorical bin using bars. A count plot can be thought of as a histogram across a categorical, instead of quantitative variables. So when in our data set the distribution of gender is given in the variable sex, we are using a palette called pastel. This will pick some colors for us and represent different colors for different type of genders. The data that we are going to use is data is equal to data, and for x we are going to use a continuous variable called income. When you will create this, you will see it in two colors. Okay, so now you can see uh, income is a categorical variable below 50k, above 50k. Gender is also a categorical variable where we can see male and female, and this will simply give us count of both values. Okay, on x-axis we have below 50k. In below 50k you can see we have more than 14,000 people male and around 9,000 people female below 50k. In above 50k we only have around 62 or 6300 people in count in male and less than 2000 people as a in female. So it is clear from the data set that more people we have are male, and this is showing us the distribution of different genders also. And for exploratory analysis we have to see the, you know relationship of different type of variables here. So now we will also see distribution of income, right? We have seen income, now we have education level also. Okay, so in the similar way as we created income count plot, we will also create educational count plot. I will provide this code to everyone. Now here you can see for education level versus income. Here we are using sns.count plot. We are using y is equal to education. The only difference here is here we use x is equal to income. You can also do that just to show different parameters we are doing it. If you will use x, you will see it like this. You can see uh, the labels will be hardly visible here. That's why we are using y, which will create a horizontal bar chart for us. And here when we will open image in new tab to visualize it properly, so you can see we have bachelors. In bachelors above 50k is around, we can say 3,500 or 3,600 something, and below 50k is that, and above 50k is around 2,200. So you can see in all the groups here below 50k is taller than above 50k, but in groups like this, in doctorate or prof school, okay, in these two groups you can see the above 50k distribution is more in the group than below 50k. So which means that the education level, if it is doctorate or professor or prof school, let me check what is this. This may be professional school. So it looks like professional school. So you can tell that here doctorate and professional school are the two places where we have candidates above 50k. The ratio of candidates is more. And in some cases like preschool, first, fourth, fifth to sixth, we have everyone in below 50k range. Next important feature for us is hours worked per week. So this is number of hours they are working per week, and that may have good effect on income. So we will simply use the same thing, but here we are using box plot. Box plot is another way of showing distribution of data. So here I have explained what is box plot. A box plot or box or whisker plot is a visualization tool that is used to summarize the distribution of data set and identify outliers. It provides a 5 number summary. So the 5 numbers are minimum, a lower whisker, the smaller value within 1.5 times the interquartile range, IQR below the first quartile. Then we have first quartile. Let me create this chart for you, then you will see. So as in Seaborn, that's why we are using Seaborn, because we have this type of interesting box plot. And we can see we have a lot of outliers also. So below 50K, above 50K, you can see two groups and you can see many outliers. Let me explain this to you. First, let's understand this. So it has minimum value, first quartile, a median value, the middle value, 50th percentile of the data, third quartile, the 75 percentile, the value below which 75% of the data falls. 25% is first quartile. So when you will see it here, let me open it in tab so that we have a bigger graph. So here you can see we have these lower and upper whiskers, right? And then we have these two values. So and I also have this explanation here how to create box plot in Python and what does it mean. So you can see this is just a horizontal box plot. You have minimum, this is whisker maximum, the lower quartile, upper quartile, and medium. And this particular thing is called box, which is called interquartile range. Okay, so that's what we are seeing in vertical format here for both age groups. And you can see number of hours here are below 40. So in below 50K, number of hours are also below 40, and we can say just above 29-30 range. Okay, so and maximum value of hours here is around 48 or 46 range, that you can see. We can get that from data also, but this is what you can get here. But here you can see minimum value is around 26, 27. The maximum value here goes up to 63, 64. That means number these people are who are earning above 50K are working usually more than 40 hours per day, maybe on an average more than 50 hours per day, sorry, per week. So what are the observations that we get from here? Median hours work. People earning above 50K tend to work more hours per week as their median is higher than those earning below 50K. Median for below 50K is around 40 hours, while for above 50K is appears slightly higher to 45, as I said. Interquartile range below 50K, the IQR is narrower in case of below 50K, this interquartile range, as I explained earlier. In case of above 50K, it is wider. Narrower interquartile range indicating less variability in hours work. So when this value is lower, that means all the points are very close to each other. Like people, most of them are working close to 40 hours per week. But when it is wider, okay, or higher, this means that more variation in hours is among these earners. So someone might be working for 42 hours, but someone might be working for 50, more than 50 hours on an average per week. Then we have whiskers. Okay, these are whiskers, these ranges. So below 50K, the range extends to both low and high hours with more lower R outliers. And in case of above 50K, you can see here, whisker is higher. So in case of above 50K, the range shows fewer people working very low hours. Okay, but there are many high R workers close to 60 to 80 hours, you can see. And we also have outliers. Both group have outliers beyond the whiskers, indicating individuals working extremely high or low hours. there are more outliers for people working fewer hours in the below 50K group. So like here you can see here there are more number of people, but here there are less number of people. Here also in below 50K there are more number of people who are working, you know, less than the lower wage scale. So this type of or this particular analysis can be done with the help of a box plot. Now there is one more thing. Let's say data dot, and we have hours of week, hours per week. Okay. Here we also can write something like dot mean. So you will get a average hours. So out of the complete data set, average hours is 40.4. But if we'll simply use group by, okay, so we will group by income. So you can see in case of below 50K, the mean value is 38.84, and in case of above 50K, mean value is 45, that we can see from the data set. If you want to see other values, like you want to see minimum, maximum, obviously there are outliers, but maximum in both cases is 99 and minimum in both cases is 1. So obviously that's why you are seeing these outliers. Okay, and you can also try to find count. So you can see, and this is something that we already use by using value counts. Because there are more people here, that's why we the likelihood of seeing more outliers is also there. Next, in the data set, we also have work class like state, government, self-employed, etc. So we will also create a count plot as we did earlier on y-axis. Palette we are going to use is Viridies. So we can use these type of palettes. These are basically color palettes, and we will order the data on the basis of work class value counts. That means the values that the work classes in which we have higher values, we will order according to that, and we will use plt.show. So you can see now it this is because of word the iridis or viridis palette that we used. If you will not use this, let's see, if we will not use this, then you will get a simple chart like this in the blue color. Okay, but when you will use palette viridis, you will see it in simple order and colors will be different. So let's open image, and as per the data we can see most of them are private. Second is self-employed, then local government, then maybe unknown, and state government, and self-employed included federal government, etc. Without pay and never worked values are very less, so we cannot even see them on the bar chart here. There is one more thing that we can do. We can save these graphs in a folder, that I will show you how to use that later. So I'm just saving them in one folder. Hist one, count one, count two. You can also write them with their title. Box one and box two. This is count three. We will simply use them later. We will put them in one report. So until now we have seen different categorical variables like work, class, education. You know, you can similarly see for marital status, occupation also, relationship also, race also, right? But I will show you just use of some numerical metrics here, like what to do to plot that. So we can use a pair plot. Up in a pair plot, we take all the numerical features like age, the final weight, education number, capital gain, capital loss, hours per week, and this will create a simple plot which will show us impact of all these variables with each other, like relationship of one variable with other variable, but we will have a matrix like graph. So first let me create that. The important thing in pair plot is you use, obviously you tell pair plot what is your data, what variables are you going to use. So put your variables in a list, and that list will provide here. Hue basically is color. So this is used to, you know, uh, categorize your data or class, do some kind of clustering in your data. So obviously scatter plots will be created, and this hue will show us in those scatter plot where where those different points are. Where are people with less than 50k income? Where are people with more than 50k income? Palette that we are going to use here is cool warm, and diagonal kind we are using IKD. I will show you. Let me see. I also have a dedicated video for SNS pair plot also, so you can watch that as well. But it will take time because we have many variables, and it is going to create a 6 by 6 grid. So let's wait. So here we have our grid here. So you can see. So here the first column represents age. KDE is equal to true. So that means we are only seeing the kernel density estimation, not distribution of age for different groups. Here these two different colors represent, you know, below 50k is this blue color, above 50k is this orange color. So you can see because we have less values, but how are they distributed? This is age versus final weight. This is age versus education number, like 5 years, 10 years, 15, etc. We have age versus capital gain. So you can see, yeah, everything is almost distributed evenly. And this is something that we can use. And here education number distribution is there. In case of education number, you can see we have value 0, 5, 10, 15, how it's distributed. So you can just create this graph and visualize it. Instead of creating pair plots and distribution plots of each of them, we can creating scatter plots and, you know, distribution plots of each of them separately. We can also do this. This will show us the effect of our income, which is our target variable, on different numerical features, or we can say vice versa, effect of different numerical features on income. For example, here you can see all the above 50k people are in this range. This is capital gain, right? They have capital gain, or they have capital gain in a huge number. So this is something that you can visualize from here. So this is basically the first part. I will provide you this code, everything you can try. We try to create these 6 different graphs for you so that you can see the use of different categorical variables, effect of different categorical variables on the target variable. What you can do, you can try with other categorical variables also that I mentioned just now, you know, before explaining this. So you can create more graph and see its effect. This is first part where we are performing EDA. In the second part, we will see how we can use machine learning algorithms, uh, particularly classification algorithms, to create a model that can classify the data on the basis of various features that will be provided. So now I have not used any color palette. I'll prefer this, and this is pair plot. Now we have all the plots. To create and arrange those images, I'm just using this. It's not necessary for you. You can simply import all the images here. You can go to insert, use image. So I will simply import them and just, you know, arrange them so that I can show it like a report. So this is work based, this is distribution, and here you can simply adjust their height, their width, everything, and you can show them here. So and you can put headings etc. over these images. This is pair plot, obviously a bigger image, so it will not be visible here, but every time you can zoom the graph and see. So if you want, you can show data like this, or you can put them in a simple document file also, and you can show that document also. So based on our exploratory analysis, these are some uh, insights that we have got from the data set. And then in the next part, we are going to perform machine learning on this particular data set. And if you have any questions related to it, you can ask it in the comment section. Here I will just enable shadow for these images using Power BI. We can also create these images natively in Power BI, that I have shown that, but this is this process that I did right now took me less time. So obviously, because little bit complicated to use the entire Python coding here. So now we have these images, we can put a simple shape here, and in the shape we can define what we were doing. So thanks for watching this video. Please subscribe to our channel for more content like this.